All right, let's go ahead and talk about this. The plan for this recording is to make you pretty good at electron configurations. If this is first hour you're watching, you've already done this, but the other hours have not. So it won't be much of a review for 5th and 6th, but we'll be all right. We'll get that rock solid. And then we're going to talk about electron dots, which is new to first hour and everyone else. So here we go. First off, let's actually go. Well, never mind. I already changed my mind. So here we go. When we do what we call electron configuration, we are putting a little formula in a language that will help us to understand how the electrons in the atom are actually organized around the nucleus. And we talked a lot about some confusing things, but all that leads to this process. And this process, it turns out, is actually extremely simple. So first thing, you'll need your periodic tables. So go ahead and take those out. If you don't have yours, you can look at the one on the wall, but it is a little bit tricky to look on that one. So now that you have those out, we are going to do this process for aluminum. And so aluminum is the symbol of Al, and when you look at your periodic table, the first thing you need to do is find the number of electrons, and that is equal to the smaller of the two values. Or if you're looking at the one on the wall, it's equal to the blue number in the top right corner, and that's 13. All right? Now, so what you would do, you find the number of electrons, and you're already halfway there. The next thing is you fill in this chart over here from the bottom up by putting 2 electrons in each box. So each one of these boxes you can account for 2 electrons. So I'm going to draw it like this. 1, 2, 3, 4. And as soon as I get full, I can go up. 5, 6, 7, 8, 9, 10. Now the rows that are the P rows, you put 1 in each box before you double any. And it's kind of tricky, but a half-filled orbit, or one of these boxes, is more stable than an empty one. So if you only have 3, you'll put 1 in each box to make the atom more stable, and then you eventually move on. All right, I'm going to erase these. It's going to be hard to erase that one, but whatever. So we're at 10 so far, so I go 11, 12, and 13. So I've gotten to the number of my electrons. The next thing I would do is write the configuration. And it's extremely simple. You start at the bottom and you list everything and how many there are in each thing. So we started with a 1s, and there are 2 in all of the s's. Then the next one up was 2s, and there were also 2 electrons. Then we went to 2p, and we would count all 6 of those and put a 6 superscript. And then we go to the 3s, and there are just 2. The next one up is 3p, and that's a 1. All right? And so all of the discussion that we've made about the atom, about those weird shapes, about everything, really comes down to what we call the electron configuration, which is this language that we could report, and that would explain how the electrons are arranged in an atom. All right? Now, let's do a couple more. In first hour, I know you've already done this, but it's a good review. Fluorine, first off, that's element F. That's element 9. So you have to account for 9 electrons. Very simple. 2 at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now from there, you write the configuration, which is 1s, and you put 2 in that box. 2s, you put 2. 2p, and you only put 5. That would be the electron configuration for fluorine. All right? Why don't you try the next one? That's helium. That should take about 10 seconds. All right, hopefully this took you about 10 seconds. Helium is He, which is element number 2, which means 2 electrons, and they both fit in the first box. 1s2. All right, now let's have you do a couple on your own. So let's have you do magnesium. And this is all on page 9, I think, is the page that we're on. We'll do magnesium. Let's do nitrogen. Let's do potassium. And I don't know. Keep going. Whatever you're doing. Do Li, boron, and then maybe that'll fill the sheet. So have the sub pause this, or if you're watching this at home, pause this and do those there on page number 9. All right, hopefully you have all of those done. I'll do at least Mg and N. So I think I have another one. Well, I don't. So we'll just ignore this part real quick. Hold on. All right, so we want Mg, I think is what I said. So magnesium, you would look, and that's element number 12. So 12 of these. Electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it ends here. I fill everything up to there. 1s2, 2s2, 2p6, 3s2. And I will be ready to go. That is how we do electron configurations. In this class, we do not go past 20. Once we fill this all up, which would be 20, the rules change a little bit, and you are not required to know to that level of understanding in this class. All right, so here we go. The next thing we need is what we're going to call the E dot, and let's go ahead and attack those notes now. And these are simple. You just follow a simple set of rules again. So electron dot symbols are a simple way of showing the outermost electron shell of an atom. And that's kind of hard to write, but outermost, I guess it fits fine. Might not on paper. The electron dot symbol for an element consists of the chemical symbol. So it's letters on the periodic table for the element plus a dot for each outer shell or valence electron. Dots are placed in 4 regions around the atomic symbol: the top, the bottom, and the left and right sides. Each of these regions can accommodate 2 electrons. Now, hopefully that seems familiar, because these are representing the boxes that we were talking about filling, and each box can only hold 2. And really in this world, it's not a box that we're putting electrons in, it's these weird shapes. And we would say, hey, one of these spheres can only have 2 electrons in it. One of these propellers could only have 1 electron, and 1 electron in each half, so that's 2. And there would be here, and here, and here, and here. All right? And so that's why these are your S's, and you'll notice here that there's only 2, and you'll notice here that each S only had 1 box. But over here, these represent your P's, and remember we had 1 cloud, 2 cloud, and 3 clouds. If you come here, that represents these 3 boxes, and in each one you could put 2. Okay, now the dot symbols are going to be very similar as well. If you, all right, we'll get this, but whatever. If you understand how the periodic table is organized, it is not necessary to memorize the order in which electrons fill. You can write the electron configuration of an element based on its location in the periodic table. All right, so let's do some dots based on these. Don't worry about this bottom part, but let's do some electron dots. So I'm going to come back here, and this was magnesium. So the first thing I'm going to do is put the element symbol of Mg. And then let me get rid of some of this stuff here. Get rid of these. Oh, that doesn't work very well. I can't get rid of those. So anyway, then from the notes it says it only deals with its outermost shell. So I'll do that in green marker. The outermost shell is the part that's in the thing. Oh, magnesium was just here, by the way. Sorry about that. The outermost thing, we go to the highest number that has anything in it, and it's 3s, and then it's everything in that part. That would be its outermost shell. And you'll notice it only had 2 electrons in the third or outermost level. And you will notice those 2 electrons were together. So we would take magnesium and we would put 2 dots just on the right side, and that would represent the electron dots for magnesium. All right, and that really would literally be done. Now, we do not put Mg with a dot and a dot. The reason why is because if you only have 2, they always pair. Okay, so this would be wrong, this would be right. And look, it doesn't matter if you put Mg and 2 dots here, or Mg and 2 dots there, or 2 dots under it. It doesn't matter where the 2 dots are, but what does matter is that they are together. Okay, let's come back and we'll look at helium. We would start here and go till we hit the highest number that has something in it. And it's just 1, and then we would look, and there are 2 dots, or 2 electrons. So we would put He, and once again, they are together. So we put 2 dots to the right. Okay, make it a little harder. We have fluorine. So we put an F, and then we come here, and we go up until we hit the highest number, and then it's everything in that level. So the highest number that has anything in it is this second level, and we have to count everything. So there are 1, 2, 3, 4, 5, 6, 7. So fluorine will have 7 dots, and they would go in this specific order. The first 2 would be together because that's representing those 2. The next 5 would go 1 here, 1 here, and 1 here. Because remember, when we drew these, I'll draw them again up here, we went 1, 2, 3 separate, and then we went 4, 5. So we go 1, 2, 3 separate, and then we go 4, 5. And that would be the electron dots. For fluorine, it would have 1 missing. Let's do one more, and that's aluminum. Aluminum, we come up and we cross out until we get to the thing that has the highest number, and I'm talking about that number right there. And then it's everything in that third level. So there are 3. So tell your lab partner right now, how many electron dots will aluminum have? Like for real, talk to them. All right, hopefully you and your lab partner said aluminum has 3. So we write the symbol for aluminum. And notice the first 2 are together. 1, 2, and then the third one's all by itself. And this would be the electron dot structure for aluminum. All right, now I want to point something out here in blue. Aluminum has 3 dots. If you have paid enough attention in this class, I think I have this somewhere, hold on. Oh, you will notice that aluminum is in family 3. When we did others, let's go back. When we did magnesium, it had 2 dots. And you will notice magnesium is in family 2. It had 2 dots. Aluminum, family 3. It had 3 dots. What else did we do? Now, helium, you're going to be super annoyed, but chemistry is this way. Helium is the only exception to the idea that the dots equal the family. Helium is in family 8, but in the top row we have a maximum of 2, so that's why it gets 2 dots. But it's the only exception. All right, fluorine. 1, 2, 3, 4, 5, 6, 7 dots. Well, tell your lab partner, what family is fluorine in? That's right. It's in family 7. So, please write this in your notes somewhere, if you didn't already. The number of dots will be equal to the family number, with the only exception being helium, because it's in that top row where the max number could be 2, because it's in the S, and you can't have more than 2 in an S. All right, so we're going to pause this, and why don't you do the electron dots for these other ones that were assigned right there on that page that we've been working on the right side. Do the dots for these. I already did that one. I'll do these and we'll review them in just a second. All right, so we already did magnesium, but we'll do it just real quick. Magnesium is in family 2, so 2 dots. Nitrogen, it's in family 5, so 5 dots. 1, 2, 3, 4, 5. And they're together in the S box, and they're alone in the P box, if you remember. All right, then potassium is in family 1, so it only has 1 dot. All right, lithium is also in family 1, so it has 1 dot. And then boron is in family 3, so it should be a B with 1, 2, 3 dots. All right. What I'm going to have the sub do now, I'm going to have you do 5 or 6 more of these on the side of the paper. I want the substitute to walk around and check those real quick to see how you're doing. So do these just on the side, the right side of that page. Now, on these we can go past number 20 because we don't really care if the rules don't apply as far as electron configurations. The dots still stay the same. So will you do the electron dots for Si? How about iodine and Sr, and then Sn, and then C, and then how about oxygen? So have the sub pause those, and then really, I don't know that we'll have the sub check, but do them together like I always do. So do them alone, I'm sorry. Then check with your lab partner to see if you got them right. If you don't have them right, will you find someone close to you that does have them right? All right, to check these real quick, we'll put the number of dots here in red around them. Si, that's in family 4, so 4 dots. 1, 2, 3, 4. Iodine is in family 7. I don't know if you'll see my marker buzzing out on the video or not, but it is. That's 7 dots. 1, 2, 3, 4, 5, 6, 7. And I know I should have done that different, but ultimately we end up with 1 alone on the bottom. Sr is in family 2. First 2 are together. And that's it. We're done with those. So, or that one. Then tin, that is also in family 4. First 2 together. So 1, 2, 3, 4. I didn't even realize I did so many in family 4. Carbon's in family 4. 1, 2, 3, 4. Oxygen's in family 6. So 6 dots. 1, 2, 3, 4, 5, 6. All right. So there are some homework problems that have both configurations and dots. Will you turn to the back and work on those homework problems? I don't know where they are, and I don't have my lab book in front of me. They're probably in the 50s or 60s. So just looking real quick on these electron configurations. This part right here in green that I'm going to circle, this is the tool you use, but this is actually the only thing you have to write for an answer. So you do not have to draw these boxes out. They're just there to help you arrange them. All right, hopefully that helped. Hopefully you have a good understanding of electron configurations and electron dots. There's 10, 12-ish of these on the exam, and hopefully everyone does fine on them.